To implement a NAND circuit, we do these 5 steps. We start with our logic expression, and we go ahead and implement the design with the regular AND or inverter logic. In the AOI implementation, we identify and replace every AND or an inverter gate with its NAND equivalent. We then redraw that circuit. We identify and eliminate any double inversions, in other words, back-to-back inverters, and then we redraw the final circuit. Let's go ahead and walk through that. Okay, here is a circuit that we want to convert to a NAND design. Notice we currently have 1, 2, 3 different IC circuits. 2 of them are using only one of their gates, and one of them is using 2 of their gates. Okay, we replace those with their NAND equivalents. So the NAND equivalent of an OR is this circuit right here. Of course, an inverter is just this, where we're tying our inputs together. And then both of these two use the NAND gate running into another NAND gate with the output from the first NAND gate tied into both inputs on the second NAND gate. We go ahead and redraw that circuit, and this is how that would look. Obviously, we just replace that inverter with a NAND gate with its inputs tied in. And then this is the implementation of a NAND to an AND. This is or an AND to a NAND, right? And then these 3 are NAND gates to OR gate, to an OR gate. We go ahead, next thing we do is we look at any double inversions. So we have double inversions here and here, and here and here. That would just, if this was outputting a 1 here, this would turn it to a 0, that would turn it back to a 1. So we can eliminate those. And that's our final circuit. We can redraw that circuit to look like this. Okay. Here's proof of equivalence, where we go through the math and prove that the 2 are equivalent to each other. And this is the whole reason. Right here's the reason. So in our AOI implementation, we had 1, 2, 3, 4 gates. Okay. And we had one OR gate, inverter gate here, the 74. We had 1 gate. The IC chip actually has 6 gates on it, but we only used 1 of them. Here on the 008, this is an AND gate. On the chip, there's 4 gates, but we only used 2 of them. And here on the OR gate, again, the chip has 4 on it, but we only used 1 of the gates. So we used a total of 3 IC chips. Over here, using NAND logic, we have the same number of gates, 1, 2, 3, 4, but they're all the same gate. And since the 74SL00 has 4 gates on it, and we used all 4 of those gates, we only needed 1 IC chip. So it saved us money on buying the chip. It also saved us money on positions on a board. The board can be a lot smaller because we're not having to put chips in line or next to each other on the board. So it saves us money anytime we do that. The next thing I want to show you is kind of a shortcut that one of my teachers taught me. Okay. And this is called bubble pushing. So what we do, we put 2 inverters in series here. So we're going to put an inverter here and an inverter here. But instead of drawing out the inverters, what we do, we know that the circle denotes an inverter. So I'm going to do 2 inverters. 1 here, 1 here, 1 here, and 1 here. Okay. First thing I'm going to do is I'm going to push this one and this one back to these AND gates and make them OR gates. Okay, so I've got an inverter bubble there and an inverter bubble up here, and so those become NAND gates right off. That means these two, that means this one, let's get that eraser working if we can, those two are gone. But that means I have an inverter here and here. Well, earlier we showed, let's buzz up and see, an OR gate is just, an OR gate is two inverters going into an AND gate, right? Well, we've already got our two inverters here, so we can replace this whole thing with just a NAND gate. So now we put our NAND gate in here, and that's done. Now, of course, we still have to do our NAND gate over here. See if I can draw that the other way. Not very well. Okay, so bubble pushing is cool because I push back, and if this was an OR gate, it would become a NOR gate, a NAND gate would become a NAND gate. And then I've got those two inverters on there that I can then get push out and change that. Basically what I'm doing is I'm pushing, changing the type and pushing those two bubbles through to the nose and changing it out for an AND gate, which then becomes a NAND gate. Cool. That's it for this lecture.